All right, dressed up a little today, not sure why, but it might make it hard to read these words down here. 8M5, lesson 10, volume. Volumes of familiar solids, cones, and cylinders. Yeah, not the most exciting lesson of the year, but we will try to just go through it kind of quickly. You have to memorize a few formulas. I'm going to give you maybe a few keys to how you might do that. Go through some sample problems, be over and done with that. Move on to lesson 11, where we learn about the volume of spheres, and then we're going to get on to a super exciting, which I like, 8M6, 15 lessons in that unit. All right, so rather than listen to just look at my beautiful face, let's go over and start doing some work on the sketch pad. All right, here we are on sketch pad. So let's go back, and again, we're just talking about volumes of familiar solid, cones, and we'll talk about what a cone is, and a cylinder. I'll do the cylinder first because it's a little bit easier. This is a little bit easier. And so we'll start there. Now, I want you to remember what we learned about in lesson 9, the volume of a rectangular prism. Well, let's look at this. A rectangular prism, this might be a stick of butter. Who knows what this is? This could be a building, but it is a rectangular, it's a three-dimensional rectangle, if you will. So all the angles are right angles. We have rectangles on each face. Now, the way you figure out the volume, as we learned, is you just multiply the length, and we'll call this the length, by the width, and then multiply it by the height. Now, we didn't go over this, but maybe your teacher did in class, I don't know, but they may have talked about the idea that, well, what if we say that the volume is the length times the width times the height? Well, what is this length times this width? Let's look at this. We could say the volume is equal to that box times the height. But what is this length times the width? What is that? If we take this thing and multiply it by this thing, it's just the area of the bottom of the object. So this length times this width is the area of the base. So you can also write the formula, not length times width times height, but you could just write the volume is the area of the base times the height. Okay, and what they want to do in here in lesson 10 is draw the analogy, or draw the comparison to how we can find the volume of the cylinder here. So let's look at this, and we're just going to say that the volume of any object that is that stands straight up in the air is the area of the base times its height. And that's true for cylinders. So we can say then that the volume of this cylinder is, what is the area of the base? What is the area of this thing? What is that? That's a circle. That's a circle if you look at it straight up and down. And the area of a circle is equal to pi r squared. Right? So the area of this base would be pi times 2 squared, but pi r squared is the general form. So the area of the base is pi r squared. And then if we wanted the volume, we'd multiply by the height times height. So we get pi r squared h. And that is our formula for the volume of a cylinder. Okay, and the units on that are going to be cubic whatever. So if these were all centimeters, the volume, so let's just pretend these were centimeters. So the way that you'd find the volume of this cylinder is you'd say pi times 2 squared times h, which is equal to 2 squared is 4 times 10 is 40. It's pi times 40, which is equal to 40 pi. And we always have to put our units on. So our units is centimeters cubed. Volume is always a cube because volume is 3 dimensions. We talked about this in lesson 9. So 40 pi centimeters cubed. Okay, so you either can use the area. If someone said the area of this circle was, 4 pi, you wouldn't even have to know the radius. You'd just say it's the area of the base, 4 pi times 10, which would be 40 pi. Okay, but you're usually given that radius in most problems. Okay, let's move on. So here's a problem where we're going to say, well, how much ice cream, let's just forget about water and air. Let's just say how much ice cream, what is the volume, this is volume, will fill this container of ice cream. Some ice cream is sold in these buckets, some is sold in kind of these rectangular prisms, but a lot of ice cream is sold in these buckets. So how many cubic inches of ice cream would be in this bucket? Well, I would say the volume is equal to, let's do a different problem. Let's make this one step more fun. All right. So I'm in the grocery store, and this is chocolate ice cream. Chocolate ice cream. And over here, I have another bucket of ice cream, and it's kind of tall and skinny. And I know that this radius here is 3 inches, but it's taller, it's 8 inches high. Which you're going to tell your mom, I want the ice cream, and this is chocolate too. You say, which do you want? It's not obvious. It is not obvious to me which one of these has more ice cream in it. But boy, you want to go home with the bigger thing of ice cream. So let's figure out the two volumes and figure out which one you want. Let's say they're both $5. Let's say they're both $5. So I want to know which one I want to buy. So you're going to pull out your lesson that you learned from Mr. Lipscomb, and you're going to say, well, the volume is pi r squared h, and that's my volume. And then over here, it's also pi r squared h. Wow, this is way more fun. Happy Cat is going to be dancing when you tell him which one has more ice cream. So let's see. So over here, we have pi times 3 squared times 8. And that is 72 pi inches cubed. Over here, we have pi times 4 squared times 6. Well, that's 16 times 6. So this one over here is 96 pi inches cubed. And so we say we want this one. Happy Cat is on the prowl, and Happy Cat says, I want this one. Wow, it's kind of weird. This one here, notice this one over here is 2 inches taller than this one, and it's a little bit skinnier, but this one is way the better deal. This one has more ice cream. And Happy Cat says meow to that. All right, let's move along. Now, cones look like this. They're ice cream. Like imagine an ice cream cone. A cone is the same, has a base, a base here that looks like a base of a cylinder. It's the same as the base of a cylinder, but it comes to a point on the other side. So that's the difference between a cone and a cylinder. A cylinder has 2 circles on either side, and a cone has a point on one side and a circle on the other side. Has a point on one side, a circle on the other. And then a cylinder has a circle on each end. Now, cones have almost the same formula as cylinders, except you divide by 3. Okay, so let's look at that real quick. So remember, the formula for the volume of a cylinder is pi r squared h. Now the volume of a cone is equal to 1/3 pi r squared h. So it's the same, except you have to divide by 3 or multiply by 1/3, same difference. So you calculate your volume the same way as the cylinder, but then you multiply by 1/3, which is like dividing by 3, same thing. So let's find the volume of this cone. So the volume is equal to 1/3 pi r squared h. So it's equal to 1/3 pi times 5 squared times 6. Well, that's equal to 1/3 pi times 150. 5 squared is 25. 25 times 6 is 150, and 1/3 of that is equal, so we go 1/3, and we can use our commutative property to move numbers around. 1/3 of 150 is 50 pi, and our units are inches, what? Cubed. Okay, there we go. So that's how we do volumes of cones. Let me see if I have another problem for you. Yeah, so let's just move straight on to homework help. Now I want you to find the volume of these objects, then I'll have a couple kind of a little bit trickier problems on the next page, but this should be very straightforward for you. Finding the volume of these objects, I'll let you use a calculator on A if you want to. Okay, so the volume of a cone is equal to 1/3 pi r squared h, and the volume of a cylinder is equal to pi r squared h. Now I want you to pause and try. You should be able to do this, but we'll see. Pause and try. All right. I assume you're back, so let's do it. Let's do this thing. Volume equals 1/3 pi. R squared is 2.5 squared times h. So I'm just going to multiply these out, and I'm going to say 2.5 squared times 7 equals, and then divided by 3 equals. So we get kind of a crazy number, but it's 14.58 pi centimeters cubed. This is rounded. This is rounded. But, you know, it's not, life doesn't always work out exactly perfect. Sometimes you get these crazy numbers. All right, over here we get pi r squared h. Pi r squared h. So we get pi times 3 squared. That's our radius of our circle, of our base, the radius of our base, times h. So that's 72. Did we already do this one? Yes, we already did this one on our ice cream problem. So 72 pi centimeters cubed. Okay, so hopefully these were straightforward. Now we're going to get into kind of the little bit trickier problems, and this is still homework help. And then we're going to be done with this this lesson. There's some good problems in the homework and the regular homework for the lesson under lesson 10 in the Eureka Math Guide. Okay, so now I'm going to take, here's what I'm going to do. I have this carton of water that is completely full, and it is a rectangular prism. And I'm going to dump it in to this. It's going to start off empty, starts empty, and we're going to fill this thing up in this direction. And then how high will it go is the question. How high will it go? And you can use 3.14 for pi. Okay, so don't use pi. So use volume equals 3.14 r squared h. And then use that. And then you can use a calculator and then go about solving this problem. And then on this side, I want you to know how much water is left to fill this cone. So notice we have a cone that is 10 inches high and has a radius of 2 inches, 4 inches, but we've filled it up to a height already of 5 inches, and the radius at that level is 2 inches. So the question is how much water will fill the rest of this cone? Okay. All right. So I want you to now pause and try. All right. Let's come back. Okay. So let's see here. Well, the first thing we have to do is we have to figure out what the volume of this guy is over here. And the volume of this is the base times the height, or just length times width times height. The base is here is 16 times the height is 10. So that's 160 centimeters cubed. So that's our volume of water over here. You could have done 4 times 4 times 10, and you'd still come up with 160. I just did base because I can kind of see it kind of quickly. All right, now let's figure out what this guy is over here. We know that the volume of this water, once we dump it in, has to be 160. So our volume is equal to 3.14 r squared h. We know our volume is 160 equals 3.14. We know our radius is 3 squared. And then how the height will be determined by what's left over. So we know all our other numbers except h. So we can say 160 divided by 3.14 divided by 9 by 3 squared is our h, right? So we're going to divide both sides by 3.14 times 3 squared. Divide this by 3.14 times, we'll just call it 9. That's 3 squared. This will cancel. And so our h is, and I'm going to my calculator right now, 160 divided by parentheses 3.14 times 9, close parentheses, equals. And so we get our height is equal to about 5.66 centimeters. So that's 5.66 centimeters. Got it? All right. There's some other problems like this on the homework. You should be able to check that out. Test against it. Do some good practice. So over here, let's figure out, well, how much water is needed to fill the rest of the cone? Well, the way I can figure this out, I don't have a good formula to figure out what's the part of a cone. So let's figure out how much to fill the whole cone. So we'll take the volume of the big cone, and we'll subtract the volume of the little cone. Right? So our big cone is this whole thing here, and that's how much will be in the whole cone. But then if we take this bit here and we subtract off this portion, then we'll know what's in here. And that's the question, is how much water is left to fill this thing? We used a trick like this in lesson 9 to do a lot of problems. Sometimes the best way to find the volume of something or the area of something is to take the big thing and subtract off the known little thing. So the volume of the big cone is 1/3 pi r squared is 4 squared times 10. That's the volume of the big cone. So that's 1/3 of, and I'll put the pi at the end. I can take this at the end and I'll put this over here. 1/3 of 160. 4 squared is 16 times 10 is 160 pi. So that's also equal to 160 over 3 pi. That's the volume of my big cone. Now the volume, this is my big cone. The volume of my small cone is 1/3 pi r squared h, which is 1/3 pi times 2 squared times 5. 2 squared is 4 times 5 is 20. So 1/3 pi times 20. And that's equal to 20 over 3 pi. And so that's my little one. All right. So if I want to subtract the big one from the little one, 160 over 3 pi minus 20 over 3 pi, that's equal to 160 over 3 minus 20 over 3 pi, which is equal to 140 over 3 pi inches cubed. Okay, so we are now done. We're done here. And so we'll head back over to our picture of me with my nice shirt on that I don't always wear. I don't always dress up a little bit nicer, but today I did. And so that's where we're at. You know, not a super exciting, grabbing lesson, just memorizing a few formulas. Pi r squared h and 1/3 pi r squared h for cones versus cylinders, and how to apply them. Tomorrow we'll do spheres, and these are standards. You have to know them. It's important to know them. I mean, if you're in the grocery store and you have to figure out which ice cream you want to buy, and you want to buy the most, you gotta know your cylinder formula. And I bet your parents may not know it. And so you want to get the best deal, so you pull out your calculator and your knowledge of volume. You're going to be well on your way to more dessert more of the time. We'll talk to you later. Over and out.